Hello, class. I have one more example here for you of setting up one of these definite integral questions where we've got some complicated shaded region and we've got to figure out what its area is. Okay, so first things first, there are 3 points in this graph that we're going to need to label if we're going to have any hope of figuring this out. So I'm going to need to label this point, and this point. This point is the first positive x-intercept of sine, which is to say that this point is at pi. So this point here is pi 0, and this dashed vertical line is x equals pi. Okay. These 2 points, those are where the graph of sine intersects the graph of 1/2. So for that, I need to solve sine of x equals 1/2, which should be a familiar thing that we've done on our unit circle in the past. Namely, this happens if you look at pi over 6 and 5 pi over 6. Okay. So this point here is pi over 6 comma 1/2. And this point here is 5 pi over 6 comma 1/2. So now we want to break this down into pieces that we can actually solve for. So let's start with this area. So I'm going to call this the red area. That's one piece of the black area. So I can drop down some vertical lines here, which will make my life easier. So that's pi over 6. That's 5 pi over 6. And I see that this is not quite a definite integral itself, the red area, but it's close to one, namely if I, as before, fill in the area below it. So I'll go ahead and fill this in a yellow highlighter, which I guess doesn't show up super well, but I guess you only need to know that I'm talking about the rectangle immediately below the red area. And so then in that instance, the red area plus the yellow area is equal to the integral from pi over 6 to 5 pi over 6 of sine of x dx. Again, the pi over 6 and 5 pi over 6 give me the left and right bounds. The x-axis is the lower bound, and then the upper bound is given by the graph sine of x. That's why these two areas together give me this definite integral. And I can calculate this definite integral using the Fundamental Theorem of Calculus. So I need the antiderivative of sine, which is minus cosine. Okay, so this is minus cosine of 5 pi over 6 minus cosine of pi over 6, which is minus root 3 over 2 minus root 3 over 2. Okay. In other words, the total of the red and yellow area is just the square root of 3. Okay, that's the total of the red and yellow area together. Okay. The yellow area, though, is itself a rectangle, so I can figure that out by coming over down here, saying the yellow area is, okay, well, the height of the yellow area is definitely 1/2, so it is 1/2 times, and then the width is the gap between pi over 6 and 5 pi over 6. This is 1/2 of 5 pi over 6 minus pi over 6, which is going to be 1/2 times 4 pi over 6, which is 2 pi over 6, which is pi over 3. Okay. So the yellow rectangle, its area is pi over 3. And so that lets us solve for the red area. Namely, the red area is going to be these two together minus the yellow area. So the red area is going to be the square root of 3 minus pi over 3. Okay, so that is part of our answer. That is one of the two shaded pieces. Now I want to focus on the other shaded piece. The other shaded piece, which I'll shade in blue, it's going to be this wedge over here. Okay. And here I have to actually squint carefully at what's going on, because this is, again, something that's not part of a definite integral. But I could sort of fill in as I've gotten used to the area below it. So that's the orange area, using all the colors. So now what's nice here is that the blue and orange area together are a rectangle. So I can go ahead and fill that in. The blue plus orange that is the width here. The width is pi minus 5 pi over 6. Times, and then the height is 1/2. Okay, which is pi over 6 times 1/2. That's pi over 12. Okay, so the blue and orange areas together, that's the area of this rectangle. That is pi over 12. But we actually have to take off the orange area, because of course the orange area was not shaded when we started this problem. Okay. So what is the orange area? Well, the orange area is itself just a definite integral. It's the integral from 5 pi over 6 to pi of sine of x, because it's the area, again, bounded on the left by pi over 6, on the right by pi, below by the x-axis, and above by the graph of sine. So the orange area is the integral from 5 pi over 6 to pi sine of x dx. And I can go ahead and calculate this. I realize that was not on the screen. The orange area, again, as I said, it's the integral from 5 pi over 6 to pi of sine of x dx, which is going to be minus cosine of x, minus cosine of pi minus cosine of 5 pi over 6. Okay. Using here that the integral of sine is minus cosine, just like it was before. Okay, so minus cosine of pi, that's minus 1, so that's plus 1. Plus, now the cosine of 5 pi over 6. And the cosine of 5 pi over 6 is minus root 3 over 2. So this is minus a minus minus root 3 over 2. So that is 3 consecutive minus signs, which is the same as 1 minus sign. So this is 1 minus the square root of 3 over 2. That is the orange area. Okay. So if I follow along, now that lets me figure out the blue area, which is the thing I needed. So the blue area is the blue plus orange area, which is pi over 12, minus the orange area, which is 1 minus root 3 over 2. Okay, and so this is going to work out to be pi over 12 minus 1 plus root 3 over 2. Okay, and so now finally, we are able to calculate the final answer. which is that the area of my black shaded region is the combination of the red and the blue. So black equals red plus blue. And so here I just have to copy, okay, what was the red? The red area was the square root of 3 minus pi over 3. Plus, and then the blue area was this pi over 12 minus 1 plus the square root of 3 over 2. Okay, so I can do a little bit of combining here. So this square root of 3 I could rewrite as 2 square root of 3 over 2 so that I can combine it with the square root of 3 over 2. This minus pi over 3, I could write that as minus 4 pi over 12 so that I can combine it with the pi over 12. And this minus 1, I'm just going to leave as a minus 1 because there's not much I can do with it. Okay, so this is 3 root 3 over 2. This is minus 3 pi over 12 minus 1, 3 root 3 over 2 minus pi over 4 minus 1. And that is our answer at last for the area that was shaded in our original question. That is the total black area there. All right. We're going to wrap up there. Now, the next thing we're going to do, just as a preview, is we're going to start talking about ways to calculate indefinite integrals that we don't just happen to already have a formula for. So far this week, in everything we've done, we've just said, okay, well, I know the integral of sine or the antiderivative of sine, or I know the antiderivative of x squared or whatever. But what if we come across a function whose antiderivative we don't know? So we're going to introduce one powerful tool for finding antiderivatives of some other functions. But until next time, be well.